Good day. Just received in was breaking news. Civilization is about to end. A comet is hurtling towards Earth, and scientists have studied and investigated this comet, and they have found that it will miss Earth. However, this comet has a unique electromagnetic signature. It seems like when this comet passes the planet Earth, it will rip all our metals that we've been mining for centuries out from Earth, from where we're using it, and we'll take it with this comet along with it. This means that, and scientists have gathered at an emergency summit in Washington with world leaders and industrial leaders, and they have found that the world as we know it will end because there will be no steel to have our cars, there will be no copper to be able to transmit electricity, there will be no consumer electronics, so our computers will be totally rendered useless as we've got nothing to power them with and nothing to operate the electronics with. Luckily, this is only an imaginary scenario. However, it does illustrate the importance of mineral processing and mining to our daily lives, even if it is invisible to most. So what is offered? My name is NDME, and I'm a process engineer with more than 20 years experience in the minerals and processing industry and mining industry in various capacities and roles. I've been involved in R&D, in consulting, in equipment sales and production. In my career, I've worked in various industries. I've worked in the industries of coal, iron ore, mineral sands, gold, PGM, steelmaking, phosphate, just to name but a few. And this YouTube channel is dedicated to technical people in the mining and process industries. The aim is to make your careers and lives better and more successful. So the YouTube channel will be discussing various aspects of the mining and minerals processing industry. And then if you go to my website, ndme-inc.com, I've got a free resources section there where there will be free training and videos, etc., that you can see, as well as I'll be creating models as I've progressed in my career. You know, you've met various people and they create models of various unit processes and ways and ore definition, and I'll offer these Excel tools that I will create and make available in the resources section. As I develop them, they'll become available there. There will also be associated with this website, there will be a Facebook channel, and the Facebook will cover more the softer issues of a career, technical career in the mining and processing industries. I will cover aspects like where would you sit at a table, why would you sit at a certain position at a table, how to handle an interview, how to handle a bully at work, how to handle a project when it's going difficultly and keeping your team motivated. So these are the aspects. So subscribe to this channel to be notified of videos, and then also go to the website where you will get free resources and discussions and blogs that you can use and evaluate. So when we're discussing mineral processing, I would just want to go through our definitions and that we can be on the same page. So essentially a mineral is a solid in nature that we mine for its elements, mostly as represented by the periodic table. However, sometimes we also mine these minerals of the minerals themselves. Take an example of carbon. Carbon is sometimes it's just graphite, and sometimes carbon is also a diamond, and this is just due to the unique crystalline structure of these elements. But minerals also, as I said, mined in and of themselves. The mineral sands industry, it's mined for the actual mineral that is there, and not just the elements. Then we also mine and process, as mineral process engineers, old wood, i.e. coal. There's that black stuff, and we separate it from the gangue, which is typically the country rock, which is just typically silicon, which we can't really burn to make anything useful of it. So now that defines a mineral. Just to say where mineral processing fits in the entire mineral processing flow sheet. Typically, we would mine a rock, and for the mineral process is involved in actually upgrading the rock to a higher value, or more of the thing that you are looking for. And then it often, typically, not always, but it goes through a hydrometallurgical or pyrometallurgical process to get out the metals and that we use in our daily lives that we are probably more familiar with. Often these hydrometallurgical and pyrometallurgical processes are very energy intensive. So you can imagine the benefit of being able to reduce the mass that you need to heat up, how much of a saving of greenhouse gas emissions, costs, electricity is saved by using a mineral processing process to upgrade the ore. And mineral processing is often really involves actually taking using a fairly low cost per ton unit process or plant and to upgrade it. So that's really the benefit of mineral processing, is it's a low cost per ton but a high volume processing unit. And I will discuss it in my other videos, each of the aspects of mineral processing, more detail, and how it fits in, and the various commodities will also be discussed. Now, to see where mineral processing touches our daily life, we can look at the mining value chain and see where mining and the commodities produced will touch our daily lives. For argument's sake, let's just go through this table here. If we look at thermal coal, I know thermal coal is probably not the best place to start because coal is often seen as a dirty mineral. It's an 18th, 19th century mineral used to generate electricity. But even till today, about 40% of our electricity is generated by thermal coal. And it is actually even doubtful that it's going to be replaced anytime soon. Yes, there's a drive in the first world countries to use less thermal coal, but even then, they will struggle to get the electricity price low enough. The reason for this being is that even renewables, although they are low cost when they are operating, remember they don't work when the sun don't shine and they don't work when the wind doesn't blow. So you need a battery, and often these batteries are pretty firstly expensive, and secondly they don't have the capacity to store enough energy to drive our industrial society very long. It's usually often a couple of hours that you, if you're lucky, can get out of these batteries to drive your economy. So thermal coal, and also the third world countries want to start living like the first world countries, and thermal coal is going to be still a big component there. And yes, we can argue about clean coal and mining it cleaner, and that's where mineral process engineers involved in as well. And personally, I do believe that thermal coal can be mined more in a more environmental friendly way, and also the burning of coal, if done right, can be done in a cleaner and more responsible way. So, but that is a discussion for another day. Then coal is also used in metallurgical coal. It's a unique type of coal, I might add. And about 20% of the world's coal that is mined is used in steel making, and it's used as a reductant to make steel. And as you can see, steel fits in so many aspects of our daily life. Infrastructure, basically the roads and the buildings we live in. The power and the electricity, it's used there. It's used in cars significantly. Normal just manufacturing. You can even if you open up a video recorder and many other devices, you'll see a bit of steel somewhere in there anyway. So it is used quite extensively in our daily lives. Nickel is mostly used as an additive to the steel making to create stainless steel, etc. And there are other additives that are also mined to make steel's properties better, i.e. manganese and chrome and stuff like that. And nickel is also used as an alloy in and of itself. It's often got very high strength and corrosion resistance properties. Then zinc is mostly used as a galvanizer of steel to improve its corrosion resistance, etc. And it's used a lot, as you can see by this diagram, in infrastructure and machinery. Bauxite or aluminium is bauxite is mined as a precursor to aluminium, and aluminium is if you have the right metal structure, can be used for to make high strength structures, like as in a car, but low weight. And you can imagine that is a great energy saving if you can have the car strength, the structure of the car as strong as it has always been with steel, but lighter, hence fuel saving. Copper, as you can see, touches on so many aspects of our daily lives. It's infrastructure, it's power and electricity, it's manufacturing, it's machinery. I mean, copper is still one of your best conductors of electricity, so you can imagine where it all fits in. It's even, you'll find it in your washing machine, dryer, at home, etc. So it is really rears its head everywhere. And the modern electrical vehicle that's starting to gain popularity, it uses a heck of a lot of copper. So there's a great expectation of copper mining and what it's going to do to society in future, and the benefits of it for society in future. Then potash and phosphate. Now, you can see that's used mostly in agriculture, and it is doubtful that our modern lifestyle and food production can be done with modern farming without these two essential minerals that we mine and upgrade as mineral process engineers. Then platinum, palladium, that is a platinum group metals, and they are used in a variety of ways, and as catalysts in the car, for argument's sake, in your exhaust, and that reduces greenhouse gas emissions. So it's an environmental cleanup technology. It's also used as a catalyst in the petrochemical industry, often used in things like to help you make some way or other form of some of the plastics and stuff that we use. And then it's also used as in jewelry and investment to a smaller extent. Then gold manufacturing, gold and its manufacturing in jewelry. And I think we are all familiar with jewelry, but and some of us are also familiar with gold as an investment product. And I will digress slightly here, is that in the great history of mankind, the 6,000-year history of mankind, that gold has reared its head in so many places, is used as a medium of exchange. And it's only recently that we use paper money like the fiat currency like the dollar. And but if you study world monetary history, usually and mostly they've all actually failed in the long run, these paper currencies. And if you want to study that in more detail and why gold is going to probably make a major comeback as a means of exchange or medium for the monetary system of the world, there's a website, goldsilver.com, with a lovely video series discussing world monetary history and why gold is so important, and why fiat currencies eventually fail. Then also mineral processing is involved intricately in the extraction of diamonds. And as you can think, every time a guy wants to marry a gal, he brings out a ring with a diamond to impress her. So you can see that mineral processing and mining affects all aspects of our daily lives, even love. Anyway, now this slide I've used is to look just at copper, but it's as a proxy for many other of the minerals that we mined, as I've discussed in the previous slides. And as you can see, these are predictions of where the consumption of copper will go even to the year 2100. And you can see it will be used in buildings and infrastructure and consumer and transport. You can see this is growing and is expected to grow even more as the car industry takes on electrical vehicles, etc. like that. So you can see that there is a general extreme increase in copper demand worldwide, and often also driven by many people in the developing world wanting to live like people in the first world. And added to this is the fact that the higher grade ores have been mined in the past, and there have been a consistent grade decline. So what this means for the mineral processing industry is that more tons will have to be mined to produce more copper and more of the other elements that we use. So the demand for mineral processing as a discipline will only continue to grow into the future. And our contribution to society has already been illustrated in the elements which we provide to modern society, but you can see the challenges will be there. And so there is a great career and opportunities for us ahead. Yeah, there will be the fluctuations in the commodity prices that goes forward, but in general there will be a trend of of more demand for copper and other elements to drive industrial society. Anyway, and now putting the mineral processing together, and just to look at just to give you a taste of the various tools and things that we use and how it fits. Now this is just a generic diagram over here, just to give you a taste. The diagram in details and stuff changes depending on the commodity and the ore resource that you are mining, but this just gives you a taste of what it is. Often, as you can see, the mining, we first dig the stuff out of the ground, and then the material gets dumped into as some sort of a feed system to feed the rest of the plants that we as mineral processors engineers develop. Now, when one studies often these flow sheets, this is probably the least glamorous part of a mineral process engineer's system, is the feed system, but it's probably generally it seems that Pareto rears its head in terms of head feed delays, meaning that the delays in terms of not getting the ore through the plant to be able to produce the commodities is often caused here. And so Pareto rears its head. It's probably 20% of the plant's downtime, 20% of the equipment which is here of the entire plant is responsible for 80% of the delays. And that seems to be almost a general trend in industry. So this just illustrates the unglamorous stepchild of the plant is probably one of the most important parts of the plant. Then once the ore is into the feeding system of the plant, you need to break often these big rocks into smaller rocks, and the reason is to liberate the minerals, because often they are very small pieces within the entire ore body, and various comminution devices are used. Here I've got a picture of an autogenous mill, but there are many other pieces of equipment that can be used, and this is part of the challenge of a mineral process engineer. There will be ball mills, rod mills, there's gyratory crushers, cone crushers, HPGRs, impact crushers, and the list goes on. Then we also use sizing. So the reason for sizing is you often have to size the pieces, the little rocks, into the right sizes for the next piece of equipment to handle them. And sizing is done often by screens, which is basically a deck with holes in it, and it vibrates as the material moves across. But we also use hydrocyclones and hydrosizers as a sizing device. And there's a lot of science goes in there as well, and vibrational studies, etc. Then probably the more glamorous part of the mineral process flow sheet is using the various unique properties of solids, i.e. its gravity properties, density, magnetic, electrostatic, surface chemistry, and size. And you can split it. Here it's just the shaking table is used, and it's using basically differences in the specific gravity of metals, of minerals, and you can see it can split it into 3 different types of streams and colors, and it's quite sometimes quite dramatic and beautiful to see. Also, in our mineral processing flow sheets, we often use a heck of a lot of water, and often our plants are in arid regions, because the ore is where the good Lord put it, and we don't have control over that, and sometimes it's in very arid regions, and even if it's not, we need to recover the water. And there we would use things like clarifiers, thickeners, etc. And there's a lot of study and science in it, and it's even, these thickeners are also involved in your municipal water recovery system, but we also use these in the mineral processing flow sheets. And then often in a lot of the commodities, actually most of them, the recovery of your mineral that you really want is about 1 to 3% of the ore resource that comes in arid mining. So 97% usually, maybe even more, has to be put somewhere. And what is often made is tailings dams. And there's quite a bit of science and study that has to go in here, because there have been quite a few disasters, and they become quite big disasters. Often if these dams burst and there are people living downstream of it, it can kill a lot of people. So the study and how you deposit it and to minimize the environmental impact is quite a big study involved in this part of the mineral processing flow sheet as well. Now, just to show that mineral process engineers and the technical people, we are really weird creatures, but maybe not as weird as some would think. And I'm proudly one of those weirdos, technical people. They did a study of the brain patterns of artists, and when they look at beautiful art, and there's a certain unique brain pattern that emerges. They did the same with mathematicians, when they showed them this equation, and their brain pattern looked the same as it would for the artist to see a thing of beauty. And I would encourage you, just as some fun, is if you've got a bit of a mathematical bent, just look at that equation a little bit further and maybe look it up. You'll find it is a bit of a mind bend. It's quite an interesting implications that it can have. Anyway, then for physicists, I mean, as a process engineer and as a person of scientific bent, often we will look at this equation here and think about it, and it is beautiful. I always joke of relativity, theory of relativity. I usually perfectly understand it in the room when somebody explains it to me. As soon as he walks out, I can't think of how the heck theory of relativity actually works. But anyway, and as process engineers, we often study this diagram in detail. And I'm sure that if my brain pattern were to be studied when I look at this thing, they'd give the same brain pattern as the artist looking at beautiful art, as the mathematician looking at that equation, and of course the physicist looking at the Einstein's equation. And I always look at this and wonder, in terms of the predictability of this tool in the 18th and 19th century to predict elements before they were even discovered, and how we can also look at chemical equations and how they work if we really understand this periodic table. So it's really a thing of extreme beauty. As an interesting aside, the periodic table is actually a 3D diagram. These lantanides and actinides actually come out of the page at one. As you can see, there's 56 is the atomic number, and there's 72. I mean, if you can think, it disrupts this whole beautiful fit, yet if it comes out of the page, it starts working. And we are also mining these elements as mineral process engineers, and that's part of the other challenge, because the future of magnetics to use in wind and turbine generation is often involved with these lantanides and actinides, and battery technology, by the way. And then just to show that not all the elements of the periodic table are in equal abundance throughout nature, and it decreases typically as you go down the periodic table. So, the reason just for this is the heavier elements are formed in the heart of stars, where they basically squash the nuclei together to form the heavier elements. But anyway, that's aside. It's just to show that there are things of beauty even in mineral processing engineering if you look below the surface, and it's quite exciting. Just to go back to what is being offered on the website is go to subscribe to this channel if you like what is being presented here and what you think is going to be covered. I also encourage you to go to the website the NDME-inc.com, and there's a free resource center, and I'll be putting all the tools, Excel tools and stuff, as I generate them as I go along. As I said, I've got a treasure trove that I'm wanting to give to people free of charge that you can use. And then, as I've mentioned, my Facebook page, where we'll discuss, and you can pass comment on the various aspects of the softer issues of a person in the mining and processing industry. And so I hope you enjoy this, and thank you very much. Ah.